In the event that we erase the boundaries, the most enticing celestial body I recognize is the one that might be extraordinary in our sky. It is this one, Betelgeuse. It's a massive red supergiant star, and if you were to position it where our Sun is, it would extend all the way out to the orbit of Jupiter. This massive, extremely unstable star is about to explode. It's not as straightforward as it seems. These enormous creatures may appear quiet in the universe, but events like the most extreme supernovae could shake everything we observe, and even things we don't. Though we cannot predict it clearly, Betelgeuse is regarded as a representation of a red supergiant star, frequently much larger than our Sun. Brian Cox, in addition to other astronomers, believes it might explode in a supernova soon. People have become more concerned about what's going to happen because the James Webb Space Telescope has been recording remarkable images of the star. When exactly will Betelgeuse erupt into a supernova, and how significant will the impact on Earth be? Let's investigate. A star in the magnificent Orion constellation shines so brightly that even ancient civilizations noticed it. Betelgeuse, the wonderful character, resides there, on the eastern shoulder of the Orion constellation. Ranking as the second largest star in Orion, its name derives from this location, marking it as a shoulder star. Betelgeuse is likely one of the brightest stars visible in the night sky. In addition to its brilliance, the star gives off an unusual shade of red that, as we will explore, signals potential danger. Humanity has long studied Betelgeuse. Greek astronomer Tmy observed it a long time ago. The first thing people recognized about stars was their color. Tmy noted that the star seemed to have a reddish-orange hue, an alarming indication. In recent years, the star has been studied by scientists with even greater accuracy, and they now have a much clearer understanding of what gives it its striking luminosity. One of these factors is that the star undergoes significant shifts in varying brightness, by as much as 0.6. Betelgeuse is a star with multiple meanings. Its brightness changes periodically. In 2019, researchers observed some brand new behaviors the star had never exhibited before. Even though Betelgeuse continued to shine, its brightness significantly diminished to a level of approximately 1.6, causing experts to investigate the reason for this irregularity. They hoped to find an explanation for why Betelgeuse was behaving so erratically. According to their findings, Betelgeuse could explode as a supernova at any given moment. Brian Cox, a renowned scientist and a distinguished professor of particle physics at the University of Manchester, and the Royal Society Professor for Public Engagement in Science, shared this alarming assessment. His opinion carries weight. He also presents popular science TV shows and shares his perspective in books. Brian Cox explained that Betelgeuse seems like a ticking time bomb, one that could erupt with little warning. To support this claim, the James Webb Space Telescope has provided substantial evidence. Despite its peculiarities, Betelgeuse's behavior has raised many questions. Why does Betelgeuse act so strangely in terms of its variability? With the new data, Betelgeuse has established itself as a candidate for a supernova. However, researchers still don't know when the explosion will occur. The fact that Betelgeuse's mass is nearly twice that of the Sun supports this classification. Generally, stars with several times the mass of the Sun are thought to be potential supernova candidates. The plot thickens. Scientists have used different tools to investigate Betelgeuse, such as the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory, to uncover mysteries surrounding the star. Their findings are still shrouded in mystery. Betelgeuse was born on the 31st of August a very long time ago, and since then the star has been offering odd signals, ensuring its future remains uncertain. They detected peculiar light waves emanating from the star, raising even more intrigue. But this wasn't the only bizarre incident. That brings us back to the variable nature of Betelgeuse, a star whose brightness changes. There were reports that Betelgeuse had regular episodes of darkness, similar to sunspots on our own Sun, but the cycles were distinct. It alternates between bright and dim phases twice as rapidly as it once did, another odd sign that Betelgeuse is misbehaving. Researchers observed that in February 2021, the star's dimming cycle reached a brightness band of about 1.61. This occurred shortly after the star had experienced a massive dimming event, marking the beginning of its abnormal behavior and raising alarms that Betelgeuse might be nearing its end. The significant dimming between 2019 and 2020, reaching its lowest level, made many experts convinced that the star would explode within the next 100,000 years. However, when Betelgeuse shone more brightly after this unprecedented dimming, things got even more confusing. Physicist Andrea Dree from the Harvard-Smithsonian Center for Astrophysics noted that the star was now 150% brighter than usual, making it the seventh brightest star in the sky. Researchers were astonished to see a red glow emerging from the southern part of the sky. The situation only became more baffling. This change sparked numerous hypotheses regarding the nature of Betelgeuse's great dimming. It's essential to highlight that not every star radiates the same red glow that Betelgeuse does. This glow marks Betelgeuse as a red supergiant star, which is the final phase of a star's life before its death. This red hue is the result of a surface temperature around 3,500 Kelvin, which is much cooler than the outer layer of the Sun, about 5,500 Kelvin. Since Betelgeuse is cooler, it emits less energy per square meter of surface, though it is much larger, and on the brink of exploding. We should also consider the extraordinary dimming event that Brian Cox questioned. Does it really mean Betelgeuse will go supernova? The fact that Betelgeuse has already entered its red supergiant phase indicates it is nearing the end of its life. A star in this phase frequently becomes dim as it dies, and this is something scientists can detect. However, Betelgeuse's recent unusual behavior has caused scientists to focus even more intently on monitoring it. Today, multiple telescopes are focused on this unidentified dimming event, attempting to gather more insights. Things continue to get more intriguing, since researchers still don't fully understand Betelgeuse's behavior. Scientists using cutting-edge instruments are watching the star closely. The James Webb Space Telescope is one of the most valuable tools since its launch in 2021, helping astronomers gather important new information about Betelgeuse. The telescope's images of the star's extraordinary dimming have demonstrated that the event caused an enormous mass ejection, roughly 400 billion times more significant than a typical coronal mass ejection. The James Webb Telescope can also observe things invisible to the human eye, such as specific light wavelengths and frequencies, making it an invaluable asset. Researchers have observed dust clouds forming on the star's surface that appear to resemble leaves in space, an odd but fascinating finding. Despite the fact that Betelgeuse is undoubtedly approaching its demise, scientists continue to watch for signs of when it will finally explode. But one thing is certain: when Betelgeuse finally does explode, it will mark an unforgettable moment in both scientific history and human experience. For weeks, perhaps even months, the night sky will be lit by the blazing remnants of this colossal star's death, its red brilliance replaced by an intense white glow that could be visible even in daylight. It will be as though a new temporary sun has been painted into the sky by the universe itself. This phenomenon, known as a Type II supernova, won't just be a spectacle. It will offer scientists a rare, real-time opportunity to observe how a massive star's core collapses, sending shockwaves and elements like carbon, oxygen, and iron across the galaxy. These elements, born in the final throes of a star's life, are the very building blocks of life on Earth. The calcium in our bones, the iron in our blood, all were forged in the heart of dying stars like Betelgeuse. Yet even as we await this celestial moment, it's humbling to realize that what we see on Earth is actually history. The light from Betelgeuse takes over 600 years to reach us. So if the star explodes today, we wouldn't witness it until centuries later. Likewise, if it has already exploded, we're only now catching the final warning signs through strange dimming patterns and surges of brightness. This time delay adds an element of cosmic mystery to everything we observe. Every flicker from Betelgeuse might already be a message from a star that's no longer there, its light still racing through the cosmos long after its death. In that sense, Betelgeuse is more than just a star. It's a living relic, a cosmic time capsule that teaches us not just about science and space, but about patience, awe, and impermanence. Its life is a symbol of cycles, of beginnings hidden in endings, and of the quiet but powerful forces shaping our universe beyond human reach. So for now, we wait. We look up. We wonder. And every time we spot that flickering red dot on Orion's shoulder, we are reminded, the universe is alive, always shifting, always creating, and always holding its greatest shows just beyond the horizon of time. Presently, the star's instability has sparked a flurry of speculation regarding its future. The advanced instruments and technologies we have at our disposal, like the space telescopes Hubble and James Webb, have given astronomers access to unprecedented insights into the behavior of this extraordinary star. Betelgeuse fluctuations in brightness are erratic. Scientists are carefully examining the data in the hopes of understanding what triggers these alterations. The star's extreme variability could be a precursor to the explosive event that will ultimately mark the end of its glorious existence. Whether or not Betelgeuse will burst within the next few years or in a much later time frame is still uncertain. But one thing is abundantly clear: cosmic surprises await, and the end of Betelgeuse will bring a spectacle of death that opens new avenues of investigation. Astronomers have studied the sky for centuries. They have observed and analyzed countless stars, but few have garnered as much attention as Betelgeuse. Its size, brightness, and unusual color have made it a subject of intense investigation. As a red supergiant, Betelgeuse is already in the final phase of its life cycle. Because of its enormous size, it will eventually exhaust its nuclear fuel, leading to its ultimate collapse. After that, it will explode into a supernova, an explosive occurrence that will release an incredible amount of energy, significantly altering the surrounding cosmic environment. Despite many concerns regarding the precise timing of Betelgeuse supernova, astronomers agree on one thing: the star will eventually die. This will be one of the universe's most important events to take place during our lifetime. The use of today's most sophisticated telescopes contributes to unraveling the mysteries of this star, providing crucial information about the processes that occur at the very end of a star's life. By studying Betelgeuse, scientists can gain deeper insights into the broader mechanics of stellar evolution. The explosion of Betelgeuse will most likely leave a lasting effect on its surrounding space, enriching the interstellar medium with substantial components. These components will eventually be incorporated into brand new planets, stars, and potentially even life forms. This cycle of creation and destruction is an essential component of the life cycle of stars, and Betelgeuse supernova will be an excellent illustration of this cosmic process. While we keep an eye on stars like Betelgeuse, astronomers are studying their evolutionary stages using cutting-edge technology to better understand the forces at play. The James Webb Space Telescope, with its unparalleled capacity to observe distant objects in the universe, is providing a wealth of data that will shape our understanding of stellar dynamics. The measurements and images captured by such telescopes are contributing to the discovery of the complex mechanisms that drive a star's evolution, from its birth to its ultimate demise. Although the death of a star may appear to be a catastrophic event, it is, in fact, a crucial step in the ongoing process of stellar evolution. The elements released by a supernova aid in the formation of new stars, planets, and potentially even life. In this sense, the death of Betelgeuse, and stars like it, is not an end, but rather a transformation that drives the birth of new celestial bodies. As such, Betelgeuse supernova will play an important role in the ongoing evolution of the universe, contributing to the creation of the components necessary for future generations of stars and planets. Until the day Betelgeuse finally explodes, astronomers will continue to observe and study its behavior, piecing together clues that will help them predict its future. The star's unpredictable dimming and brightening cycles, as well as its other unusual behaviors, make it a fascinating subject of study. With every new discovery, researchers are gaining more knowledge about the processes that govern the life cycle of stars, and consequently, the evolution of the universe itself. The mystery surrounding the fate of Betelgeuse serves as a constant reminder of the vastness and complexity of the cosmos. The universe is filled with untold wonders, and the study of celestial bodies like Betelgeuse allows us to glimpse the incredible processes that shape the fabric of reality. As we continue to explore the universe and enhance our understanding of the forces that govern it, we are reminded of the fragile, transient nature of life itself. Betelgeuse and other stars shine brightly in the night sky, offering a glimpse into the extraordinary and ever-evolving universe in which we live. As Betelgeuse research continues, astronomers are uncovering more details about its complex nature. The star's vast size and unstable behavior offer valuable insights into the stages of massive stars and stellar formation. Stellar evolution is both awe-inspiring and mysterious, and Betelgeuse provides an outstanding case study because of its proximity and peculiarities. One of the most intriguing aspects of Betelgeuse is the possibility that its supernova will not only affect the local cosmic environment, but also provide an extraordinary opportunity to observe such an event in real time. Using modern instruments such as the James Webb Space Telescope, scientists can now examine the star's surface, behavior, and surrounding dust clouds, allowing them to refine their models of stellar death. Such observations are vital to understanding the enormous forces at work as a star like Betelgeuse transitions from a red giant to the explosive phase of its life cycle. The eventual explosion will produce a shock wave that will influence nearby regions of space. This process will enrich the interstellar medium with essential components that contribute to the formation of new stars and planetary systems. In the end, the death of Betelgeuse will play a role in the ongoing evolution of the universe, underscoring the interconnectedness of. As scientists await this dramatic transformation, their observations serve a dual purpose, not only to witness a rare cosmic event but also to refine our broader understanding of astrophysics. Each piece of data gathered from Betelgeuse adds to a growing body of knowledge that could help unlock secrets of how stars live and die across the universe. Betelgeuse, due to its proximity to Earth, approximately 700 light-years away, offers a rare opportunity to study a supernova precursor in such detail. Most stars that go supernova are far more distant, making it difficult to gather high-resolution data. But with Betelgeuse, astronomers can monitor surface activity, gas ejections, and spectral shifts in near real time. This close observation allows scientists to test and improve models of stellar interiors and predict the exact signatures that precede a supernova. These advancements not only deepen our understanding of Betelgeuse but also improve our ability to detect and interpret similar phenomena in other galaxies. Meanwhile, the public's fascination with Betelgeuse continues to grow. The idea that a star we can see with the naked eye might explode within our lifetime captures the imagination. Some even hope to witness it light up the sky, a supernova so bright it could be visible during the day for weeks, possibly even casting shadows at night. Such an event would not pose any danger to Earth but would be one of the most spectacular celestial sights ever recorded in human history. Yet, despite all our technological advancements and careful study, the exact moment of Betelgeuse's demise remains shrouded in mystery. It could happen tomorrow or 100,000 years from now. The uncertainty is a humbling reminder of the limits of human knowledge when faced with the vast, complex machinery of the universe. As we look up at the night sky and see Betelgeuse glowing red among the stars, we are witnessing not just a distant sun but a ticking cosmic clock, one that will, eventually, stop. When it does, the echoes of its death will ripple across space, seeding new life, new worlds, and new mysteries for generations of astronomers to unravel. In this way, Betelgeuse's story becomes not only a tale of endings but of beginnings. It's a symbol of transformation on a cosmic scale, a reminder that even in destruction, the universe sows the seeds of creation. And so, we wait, watching, wondering, learning, with our eyes and instruments trained on a red giant nearing its fate. Whatever comes, Betelgeuse will leave behind more than just stardust. It will leave behind a legacy of curiosity, discovery, and awe that continues to push the boundaries of what we know about the universe and our place within it.